So in this video we're going to work out the equation of a parabola using the turning point form. So this is our general form for a parabola in turning point form, where a is the number out here in front of the brackets, in front of the x, and it reflects and dilates. So basically if it's positive, it'll be a smiley face like that. If it's negative, it will be a frowny face upside down. The closer it gets to 0, the wider it goes. Okay, so the closer it gets to 0, the wider it goes like that, and the further away it gets from 0, the narrower it goes. Now, h is the translation, the horizontal translation, how far it goes left and right from the origin. So if you've just got a normal parabola y equals x squared, that will be set at the origin at 0, 0. So the h value, it translates it left or right, and the k value translates up and down. Essentially, the turning point of the parabola is that point hk. So knowing all that, let's have a look and try and determine the equation that fits the path of the cannonball in the graph below. So the first thing that we'll do is we'll look for that turning point, the h and the k, and work out the actual coordinate. So the h for that, how far across is it? Well, let's just be careful with our scales here. It's 10 here, it's 20 here, so we're going 12, 14, 16, 18. So it's right here on 12, so h is 12. Our k is how far it's been translated upwards. Okay, so it's been translated upwards by 30. So if we're using that basic form, let's write out our basic form for a turning point version of a parabola. I'm going to put in a. At this stage I don't know what a is. We're going to come back to that. At the moment I know it's negative because it's upside down like that. It's a frowny face. But I can substitute in to this formula, h being 12, squaring here, and k being 30. So far I've already got some points on the board, or marks if this was an exam, for just doing that part. Okay, so just substituting in those values. It's a minus here because that's what the formula says to do, so just leave it like that. Now we come to, I suppose the next part's a little bit trickier, and that's trying to work out the a value. So to work out the a value, we need to find a coordinate that's on this parabola that neatly crosses over two grid lines. So if I'm looking here, I'll be looking through and going, okay, where can I find something that neatly crosses over? This one here might kind of look pretty good. That might be 520. I don't know that is for sure. I'm half thinking about 0, 0, but I don't know that that neatly crosses. I think the part that crosses really nicely is this coordinate here. So that's what I'm going to use. Zoomed in here, and now that's crossed by 2 and up by 10. So that's the coordinate 2, 10. Cross by 2, up by 10. Now that tells us an x and y value that is going to be on here. So basically what we're going to do is we're going to substitute in, we're going to say at 2, 10, x being 2, y being 10, I'm going to put those x and y values into this to work out the a value. So y, instead of writing y, I'm going to write 10. A I'm going to keep as a because that's what I'm trying to find. The x is going to be 2 minus 12 all squared plus 30. Okay, and now if we try and solve, we've got a sort of being the only variable now, so we should be able to work out what that is. So if we just have a look here, we do what's in brackets first. 2 minus 12 is negative 10. Negative 10 getting squared. Now, negative 10 in brackets there, it's getting squared. Now, that gives positive 100. Negative 10 times by negative 10 is what that is 100. So it's a times by 100 essentially here. So a times by 100 we would usually write as 100a. We've still got plus 30 on here, so that's taking care of everything in the brackets here. Everything in the brackets there essentially, if you do it out, it's going to give you 100, and we're timesing by a, that's why it's 100a there. We're plussing the 30 on the end, and over on this side we've still got our 10. And now we've just got a simple equation that we need to solve. So we look at it and say, what's happening to A? A is getting times by 100. It's then having 30 added. So the first step is to subtract 30 from both sides. When you do that, we get negative 20 on this side. And over here we've got 100A, and that 30 is now gone. And the last thing to get A by itself is to get rid of the times 100. And you get rid of a times 100 by dividing both sides by 100. And so that leaves us with A equaling negative 20 over 100. Now at this stage you could get out your calculator, that's no real drama, but let's see, we can divide both sides by 10. Negative 2 over 10 is negative 1/5, or if you put it on the calculator and press STD, it will tell you negative 0.2. Now you can write that either way, it doesn't really matter. Now we're nearly done. So we've basically got to come back up to this what we had here, which was nearly the equation. The only thing that was missing was the A value here. So I'm going to rewrite exactly what I've got here in the red box, but now I know A, I can enter that in as either negative 1/5 or negative 0.2. So just rewriting y equals, I'll do it as the decimal, x minus 12 all squared plus 30. Okay? And that should give us the equation of the line there. Now let's see if you can do it. You can have a look down here at the next parabola and see if you can do one of those for yourself. You might want to pause the video or go back and check the other one before I do the solutions for this one. Okay, if you're after the solution for it, let's see if we can do this one. We might be able to do this one fairly quickly. Let's have a look at our h value for the turning point, our h value. Remember this is hk here. H is across by 12. It's been shifted across by 12 and moved up by, each of these are going up by 1. So our k for this one is equal to 11. So we can start off by writing y equals a x minus h squared plus k is our general formula. So y equals a, we'll leave that there as a and come back to it, x minus 12 all squared plus 11. Now to work out our a value, we need to find a point that's nice and neatly on the line. Now I would be tempted here, if we zoom in, you get a better look, I'm tempted here to do over here 0, 5, but I don't think that's nice and neatly on the line. We've zoomed in really well. We can probably see, I would say that this one here, oh geez, let's see, maybe this one here might be nice and neatly on the line. It's moved a little bit when I've done that. Let's go, yep, here. It's across 5 and up 9. So remember that's going to be an x value and a y value, x first and y second. And if we substitute those values in now, x equal to 5, y equal to 9. So we say at 5, 9. And I like to put the x and the y above so I don't get them confused. I'm now subbing in 9 for y. We're going to have a, because that's what we're going to try and find, 5 for x, minus 12 getting squared, plus 11. Now this is where people tend to struggle maybe a little bit. If we just look at what we've got in the brackets here, and remember that's going to get times by a, so 5 minus 12 is negative 7. Negative 7 getting squared is the same as positive 7 getting squared because the negative is getting squared, so that's going to be 49. So it's going to be 49a plus 11 is going to be equal to 9. And we go through our order of operations now, and we go, let's subtract 11 from both sides. Now that's going to give us negative 2 equal to 49a, and then let's divide both sides by 49. A will equal negative 2 over 49. Now we could change that to a decimal. but I would suggest that we keep that one there as a fraction. And so if we go back to, let's remember this again, we go back to this original one here. We're going to substitute in our a value being -2 over 49. And then x minus 12 all squared plus 11. That will be our final solution. Now I can check this on Desmos, or I can check these on Desmos by going back to what we had originally and substituting in. So if I enter in y equals -2 on 49, brackets x minus 12 all squared, and then I plus the 11, we can see that it nice and neatly matches over the top of that parabola.